ever wondered what happens to corn husks after you eat the corn? Well, it turns out that these husks are actually considered as waste. To utilize this agricultural waste, we came up with our study, the characterization of the physical properties of Bacillus thuringiensis corn husk through alkalization.
During the past few years, the increasing awareness toward environmental issues such as the depletion of petroleum resources, the greenhouse effect, and the shortage of landfill spaces has stimulated industries to use sustainable materials instead of conventional synthetic materials. These sustainable materials should be based on renewable resources, it should be biodegradable or recyclable, and should not cause any harmful emission during production, use, and disposal. They must be at par with conventional materials in terms of quality and price. Agricultural byproducts, or also known as agricultural residues, are secondary or incidental products from production. Examples of these are corn husks, rice straw, and rice husks. According to a study by Asheri and Norbach, research regarding agricultural byproducts is necessary because harmful activities such as burning of these field leftovers is a very common practice. Farmers in the rural community can also benefit by adding value to their products, thus increasing their income.
Joke lang. Bacillus thuringiensis or BT corn is a genetically modified organism that is enhanced to improve its quality and provide protection from pests. BT corn hybrids differ to non-BT corn not only in the genetic makeup that creates the BT protein but also in some additional genetic codes. A soil bacterium, Bacillus thuringiensis, serves as a donor organism in BT corn. It also produces many cry1AB proteins that can kill larval caterpillars. A study done by Saxena and Stotsky in 2001 has revealed that the expression of this cry1AB protein has resulted to a higher lignin content in the vascular bundle sheaths of BT corn compared to non-BT corn. And lignin is one of the components of natural fibers. Plant-based fibers contain cellulose and non-cellulose materials such as hemicellulose, pectin, and lignin. Cellulose is a semi-crystalline polysaccharide that adds strength and rigidity to the fibers. Pectin is a class of plant cell wall that holds the fibers together, and lignin acts as a binder to the cellulose fibers and adds strength and stiffness to the cell walls. In 2004, a team from the University of Nebraska's Department of Textiles, Merchandising, and Fashion Design has found a way to convert corn husks into textile fibers. Results have shown that the corn husk fibers have better elongations, higher stretchability, and higher dye pickup content compared to other natural fibers. The team has made a red yarn sweater prototype from polyester fibers and BT corn fibers. Joke lang.
The physical properties of fibers are properties that can be measured or observed without changing the composition of its matter. They are important in determining the suitability of fibers from different industrial materials. Fiber yield is the amount of fiber. Fiber yield is the amount of fiber after that. Wait, that is derived na siguro.
Go.
Fiber yield is the amount of fiber derived from BT corn husk after the alkalization process and drying. It is usually expressed as a percentage. Diameter. It is a distance through a center from one side to another. Length. It is the distance from one end to other end. Alkalization process. It is a common chemical process. It's a common chemical method applied to plant fibers. Proper alkalization can enhance tensile performance and thermal resistance of agro-residual fibers. Ish. Sucks, it sucks.
And this is our objectives of our study. Our general objective is to measure the physical properties of BT corn husk fibers from alkalization. And our specific objectives are first, to extract fibers from BT corn husk to be used for characterization. Second, to determine the fiber yield, diameter, and length of extracted BT corn husk fibers when subjected to alkylation treatments with NaOH concentrations of 5 grams per liter and 10 grams per liter. And lastly, we aim to compare the fiber yield, diameter, and length of the extracted fibers from BT corn husk after alkalization treatment with NaOH concentrations of 5 grams per liter and 10 grams per liter. And our study aims to characterize the physical properties of BT corn husk fibers.
For our methods, for the collection of BT corn husks, the husks were obtained from a sweet corn vendor near Harrow Market. It was then stored at the PSHS WBC storage lab prior to fiber extraction. For the extraction of fibers, 3 setups of 50 grams of corn husks were placed in a container containing 5 grams per liter NaOH concentration, and another 3 setup was placed in a container with a 10 grams per liter NaOH concentration. The beakers were then placed in a hot plate for 60 minutes. After the boiling, the fibers were rinsed for 5 times in 50 ml acetic acid and then rinsed in a 50 ml 10% solution of acetic acid and then rinse again until pH 7 is reached. For the evaluation of the physical properties after the drying of 48 hours, the fiber weight was measured using an analytical balance. 15 samples were descriptively and inferentially measured for the fiber diameter and fiber length. For the data analysis, the t-test was used to determine the significant differences between the 2 independent samples of the study. So here are the pictures of our method. So this is the date corn husk, and then the boiling, and then the extracted fibers after boiling. For the results, the fiber yield, as you can see in the table, the 5 grams per liter NaOH concentration has a 14.89% fiber yield with a 10 grams per liter concentration has 16.74%. The p-test value is less than 1. This is not significant.
Nag-pause ko pala. Yun lang. Pero ano?
Okay. Similar to the fiber yield, the fiber diameter has no significant difference in the study. The 5 grams per liter concentration is 817.7 micrometers as diameter, and the 10 grams per liter concentration has 723.7 micrometers. The fiber length, the 5 gram per liter NaOH concentration has 8.11 centimeters, and the 10 grams per liter NaOH concentration is 5.3 centimeters. The p-value for this is 0.022, and it is significant. So, the results obtained from this research proves that this BT corn husk fibers can be used as natural fiber composites, or it can also be used in modern industrial materials such as the automotive industry. For our conclusion,
BT corn husk fibers can be extracted through alkalization. The fiber yield and diameter of fibers treated with 5 grams per liter and 10 grams per liter NaOH concentrations were comparable in terms of physical properties, while fiber length was not physically comparable.
and for our recommendations,
It is recommended to use BT corn husks. It is recommended to use BT corn husks with the same age and condition. Use different concentration of NaOH at the same time. Okay.
Salat
And
ganun.
use different concentration of NaH and cooking time. Conduct the boiling of 5 grams per liter and 10 grams per liter at the same time.
Yay, sir. Thank you, sir. Bye.
Yes.